Welcome to exercise 45-1. Pivot tables, our first exercise in pivot tables. And in this particular exercise, we are analyzing this data set here, which is a series of data points that represent defects for a company, Contasso Limited. So we're provided with some data here, but before we get into the data, I just want to clean this up to follow some best practices. So we're going to get rid of these blank columns here to the left. We're going to get rid of the blank rows here at the top. All right, and so what we see is the data that we have operators. There are two operators, A and B. We have machine. Machines are, there's 4 machines, machine 1 to machine 4, the day of the week, and then this defect, this column D, is not labeled very well. It's not very descriptive because this actually represents the defect type, and there are 5 defect types. One may, oops, didn't want to do that. One may easily mistake this for a quantity of defects. So we're just going to change this field to call it defect type. All right, and that will just make our pivot table a little easier to understand as well. So at this point, just to get an idea of the data, I just want to, I'm just going to pop down to the bottom. I just want to see how many records we have here. So we have 166 records. Not a huge data set, but certainly one that we wouldn't be able to just look at the data table itself and make any sense of it. So let's go back up to the top. All right, before we get started creating pivot tables, what I'd like to do is to change the sheet name here to data. Now, don't forget to also add a documentation page. I'm going to skip that for the tutorials because that may just become, again, too redundant for every tutorial. So essentially, what we have are really all dimensions. We have the operator, machine, day, and defect type. So I think what I'd like to do is start thinking about the kinds of questions that we would want to answer. I'd like to know what operator has the most defects, what machine has the most defects, what day of the week has the most defects, and then, of course, very important, which defect type seems to appear the most in our data set. And then I think if we create a series of pivot tables, what we should start to see is a picture that evolves in terms of where Contasso needs to focus. All right, so I'm just going to get rid of these 2 worksheets. We will end up creating a new one for the pivot tables, but I'm just going to create some space here. So to create a pivot table, just select any cell inside the data table. And what we're going to do now is to select insert and pivot table. All right, so we're going to create a pivot table with this data range, A1 to D166. And we always want to select a new worksheet. Or an existing worksheet, but never ever create a pivot table on the same worksheet as your data. And the reason for that, and it's very important, is that if I filter the pivot table, if I expand it and then delete it, what can actually happen is rows within my pivot table can actually rows within my worksheet can be deleted. And imagine, if we had our pivot tables on the same sheet as the data, and we remove some data from the pivot table, that's going to remove some data from our data table, which will corrupt the data, which will mean our analysis is of not high quality because we've corrupted the data. Okay, so we're going to create a new worksheet. Hit OK. All right, so we're presented then on the right-hand panel of the pivot table window with our field list. And what I'd like to do is I'm first going to create what's called a cross-tab query, or cross-tab pivot, sorry. What I'd like to know is I'd like to know the day of the week. I'm going to make that my rows. So I've got my rows now. You can see the row label. I'm just going to rename that. We're going to call that day of the week. And what I'd like to have for my, my columns in a cross-tab pivot table, what you're going to have is the rows and the columns are going to be 2 different ways of grouping the data. Those are called dimensions. So we're going to have 1 dimension with the rows, 1 dimension with the columns. And as we identified in the lecture, when those dimensions do not relate to each other, you should never put them in either both column or both rows, as this becomes just confusing with pivot tables. So again, we're going to use the crosstab. Now we're going to change this column label up here. I'm just double clicking, and this is going to be, again, defect type. So just note that. Now, the interesting thing about this data is that we actually don't have any quantitative data that appears to us. So I can't total like a quantity. There's no sum. I can't average. So in fact, what we're going to assume is that each one of those lines represents one defect, or each one of those rows or records. So in this case, then, if I want to calculate the number of, what we're going to do is we're going to count the number of records, or the number of times, for example, a defect 1 occurs on a Monday. So we can actually use any one of these fields to bring down into our values. And remember, values is where we calculate our measures within our pivot table. So that's our calculations. Now, when we immediately drop down a numeric field like defect type, you're going to see that Excel wants to sum it. It wants to add it up. So if we think about the data, and just go back to the data for a second, we have a defect type 2 and a defect type 3. Both of those occurred on operator with operator A, machine 1, and on Monday. And imagine if we're summarizing this, we don't want the total to be 5, we want the total to be 2, representing one defect, operator 1, machine 1, Monday, defect type 2, and the second record here, operator A, machine 1, day, Monday, defect type 3. Okay, so all that to say, what we want to do now is we want to change the values. And the easiest way to do that, and there's always a couple different ways, is I'm just going to double click down here in my field list. And I'm going to select value field settings. So in the value field settings, as you can see, it defaults to sum. We're going to change this to a count of defect types and hit OK. So now we're actually seeing that there are 165 defects reported in our data set, which makes sense because the data set actually went down to row 166 and there was one row for a title. Okay, so now what we're seeing is, oops, don't want to do that. So now what we're seeing is basically, if we look at this pivot table, if we look at, let's say, this intersection right here, what we can say is on Monday, there were 10 reports of defect type 1. We go across to the right, there were 6 defect type 2 on Monday, 6 defect type 3, 3 defect types 4, and 2 defect type 5. If we then go over to the grand total, what we can see is there was a total of 27 defects reported on Monday. Now, if I'm wanting to then analyze this pivot table and make sense of it, and remember what we're trying to do is prioritize where Contasso needs to focus their energies to solve their defects. What I'd like to do is to change this from, instead of just counting and showing me the numeric value, I'd like to show the value as a percentage of all the defects. So what I want to see now is a distribution of defects, not the actual numbers themselves. Now to do that, we're going to go back to changing the value field settings. And let me show you a second way to do that. I believe if we simply double click or right click, no, we double click here. No, we double click on, sorry, just messing that up. But what I wanted to show you, if you double click on a particular value within a pivot table, what happens is a new sheet is created. And what this sheet is, since I selected defect type 1 on Mondays, what we get is a subset of the data contained from the data table in this sheet so that we can see this data. So I'm just going to delete that. We don't need that. That's fine. Okay, so I'm just going to go back to value field settings by selecting down here in my field list, value field settings. Now, as we can see, we have the numeric value of the count or the number of occurrences of a defect, and I want to change the way this is shown. So rather than showing the value as the discrete number, what I like to do is show it as, again, a relative percentage. So I'm going to select the show values as, and what we can see is we have where it says no calculation. I'm going to select that pull down so we can see some of the options here. So essentially what we can do is we can change the way we display the data by looking at percentages, which again is this distribution. And there's some percentages of grand total, column total, row total. We can also look at differences, running totals, percent running totals, and you can also rank in here as well. Now, and again, in this case, I want to get an idea of what is the distribution. So I'm going to do, I would like all the values in my pivot table to show as a percentage of the grand total. That is, what percentage of 165 defects represents Monday type 1, for example. So we're going to select that, and I'm going to hit enter or OK. Now, what we can see, and changes the way the data is shown in the pivot table, is what we can see here is we can see that if I was to read this pivot table, now if we look at the distribution, if I look at Monday defect type 1, what we can see is that represents 6% of our defects reported for the week. Now that doesn't tell us a whole bunch. So what we're going to look for here is any very large numbers. Okay, we've got 12% of defect type 2, or 12% of all the defects reported were type 2 on Wednesdays. Okay, that's a little higher. So that's not telling me a whole bunch, I think, inside the data table. So what I want to do is I want to look at these totals. First, I'm going to look at the row totals. And if we look at the row totals, these represent the total distribution by day. And what I can see right away is that Wednesdays appears to have, well, quite a bit of a larger distribution of defects, because if these were equally distributed, they would all be 20%. So what I'm going to do is just highlight that. Okay. So I'm highlighting values right now that really stand out for me. And then once we create all our pivot tables, we can make some observations and some analysis from here. Okay, so that's looking at by day. Now, if I look at this row 10 here, this grand total, what I'm looking at is the distribution of defect types. And if we look across here, defect type 1 has almost 40% of all defects, defect 2, 26, then 19, 12, and just simply about 2.5%. So to me, I'm going to highlight both 1 and 2 because, again, they stand out. They stand out in terms of the highest number of defects. The last thing I want to do here is I want to put a title on this pivot table, again, just to follow best practices. So this is going to be, I'm going to say the number of defects. So that is our measure, which is the data inside the pivot table. Number of defects, and I guess we'll call it distribution. Now, by represents then, we're going to specify what are the dimensions. So the dimensions here are how we're grouping the data. So by day and defect type. So now we have a title. We'll make that nice and bold. Maybe increase the size of the font, make it stand out. All right. Now, we have some more questions to answer, and I'm not going to record them all because what I'd like to do is have you try to create the next few pivot tables. And then what we'll do is we'll come back, I'm going to pause the video, we'll come back with all the pivot tables created, and then we'll start to make some observations and again, some analyses of what we're seeing. But just before I do that, what I'd like to do is to show you a little hint. If you want to create a second pivot table, I do want to create it on this sheet. It's okay to have more than one pivot table on a sheet, remember, just not the pivot table with the data. So I'm going to select my pivot table. I'm going to copy it, and I'm going to, now I want to leave a little space in between in case I decide to expand or manipulate that pivot table. I'm going to come down about 3 or 4 rows. I'm going to paste this. So now I have the second pivot table. And in this case, I can select the data. And what I'd recommend is to keep the same format essentially for each pivot table, and do an analysis by the different dimensions. So let's do an analysis by day, which we've done. The second pivot table should be an analysis by machine and defect type. So leave the same layout, but just change the day from, well, let's do it together. So what we'll do is we'll just come down here to this pivot table. We're going to switch out day to machine. So I'm going to grab the machine, bring it down and nest it. Now, when we nest it, we've got now a hierarchy of day and machine. And as I mentioned earlier, these pivot tables really don't become, they're very hard to interpret and analyze. So I don't necessarily recommend nested pivot tables unless, again, the dimensions relate to each other. And what I mean by relate to each other, normally a parent-child relationship like year and month, product grouping and product, country and province. That would be examples. Okay, so I'm going to then eliminate the day just by getting rid of it. Got to change up our labels here. So this is machine. And then this is, now we can say the number of defects distribution by, instead of day, this is by machine. So the question then becomes now, which machine tends to create the highest number of defects? And I'm going to let you analyze that. So I'm going to pause the video, do this by machine, by operator, and there's one other question I'd like you to answer, which is which machines are run by which operators? Can you tell me that? Okay, so I'm going to pause the video and then we'll come back with all our pivot tables created. Okay, so we're back now, and at this point you should actually have four pivot tables created. Now I went to my solution and I'm just going to change this. So this is the number of defects distribution by day and okay, so we have our first pivot table, which we identified. Wednesdays were the highest, had the highest distribution at 29%. More importantly, now if we look at the machines, okay, so I have my machines in my second pivot table, we can see machine number 1 creates approximately, well, 37% of overall defects. So that's really interesting. In machine 2, about 20%. If we look at the operators, what we can see is operators A and B are 57% and 42% respectively. Now, to find out the last piece, which is the number of defects, which operators run which machines, I did a crosstab query here with operators and machines, and just counted again the number of defects. And what we can see essentially is that operator A only runs machine 1 and operator B runs machine 2. So now that we've sort of whittled this down to make some recommendations and analyses, what we're looking for is really the highest, again, those highest values relative to other values in the distribution. So if I was to look at this, I definitely would be looking to prioritize on defect type 1 and 2. So to just make a note of this, I'm going to insert a text box. So we'll just insert a text box here in our pivot table. And you may notice, just above here, I did write down the questions to ask and then the answers here, which are going to lead me really to my conclusion sort of analysis. So I think basically if we were to, and we were asked, again, where should Contaso, where should they be prioritizing? They should really prioritize defect types 1 and 2. So we can say if Contaso focuses say resolving defect types 1 and 2, then they should see a, now in this case, if we add basically 40 and 26%, they should see about a 66% reduction in defects. I would also recommend, if we look at the machines, that really probably looking at machine 1 and machine 2, because again, that gets us to about 56% of our distribution, and that includes operator 1, that again, by focusing and trying to find the root cause, that should help us. So we might want to also say the improvement should include operator A, and looking at, let's say, machines 1 and 2 to find the root cause. That's always what we're trying to do with defect analysis, is to find the root cause of defect types 1 and 2. Right, and that, I think, adequately captures the essence of the analysis of these pivot tables. So in summary, what we've done is taken a relatively small data set, but one that couldn't be analyzed by looking at the data table, did a series of pivot tables, crosstab pivot tables, to better understand, again, the distribution and what's happening. And we were able to make some, I think, some good assumptions, not good assumptions, good analysis to focus Contesto. Couple Excel pieces here, just to note, you can see that we have a documentation page, we've got our data, and we should also be renaming our pivot table, in this case, pivot table worksheet, which is our defect summary. All right, and that would be the end of this exercise.